Okay, same packet, and now we're starting with number 24. So this question, the most important thing is it's asking for the absolute minimum. So for the absolute minimum, you always want to check the endpoints and then any critical points. So we have to see if there's any critical points, and we'll do that by finding the derivative of the function. And set it equal to 0. And you can divide everything by 6. And you'll get two solutions. So we have to test them both. Okay, so you're going to take all these values and you substitute them here into the original function, and you will get the following values. And you're looking for the absolute minimum, so the smallest number here is -7, and it's saying what is the absolute minimum? It's -7, and so that was choice A. Okay, number 28. So we're looking for a point of inflection, so you get that by finding the second derivative. So the first derivative is this. And then we have to find the derivative again. And we're going to set that equal to 0. Okay, now this is a non-calculator question. So the question is, when is negative sign of something equal to cosine of that thing? So let me just give you the answer in advance, that it's B. So in case you got this right, you could just move on. So because it's multiple choice, an easy way for you to do this is to try each one of them. So if you start with A, which is pi over 4, you're going to see if this is true. Okay, now remember, you don't have a calculator. So pi over 4, pi is equal to 180, so pi over 4 is really just 180 over 4, which is 45 degrees. Okay, so if you think of your unit circle, (45° would be right there. And hopefully by now you know that sine and cosine of 45 degrees is 1 over radical 2. And this is something that you need to know because it's the 45 degrees is the only angle where sine and cosine are equal to each other. So this is the cosine, this is sine. So is negative sine of pi over 4, so is negative sine equal to cosine of pi over 4? No. And therefore A cannot be the answer. Okay, so let's go to the next one. I'm going to leave my unit circle because we're going to need that. Okay, so B is 3 pi over 4. So remember, I said that pi is equal to 180. So it's 3 times 180 over 4. And that is equal to 135 degrees. So 135 degrees would be over here. So you're traveling here 90 degrees, and then you're going an extra 45 degrees to get to right here. Okay? Let's get rid of all this. Okay, so we want the x and y coordinates. Let me take this one out. Okay, for 135 degrees. So if we went around 135 degrees, then when I drop this perpendicular, we know that we're left with 45 degrees here. So that means that this is a 45, 45, 90 triangle. So your x and y coordinates are still going to be 1 over radical 2 and 1 over radical 2, but the difference is that the x-coordinate here is negative. Okay, so this is cosine, and this is sine. So let's substitute and see if it works. So negative sine is equal to cosine. Yes, that works. So therefore, B was the correct answer. And if that wasn't the correct answer, you would keep going until you found one. Okay, now we're up to number 79, and now we're getting into the problems that you can use a calculator for, except for this question in particular. That's not going to help you, but that's besides the point. Okay, so this is a picture of f prime, and you have to figure out which was the original function, and this looks a little blurry to me, so, but you have the copy in front of you. So if this one is f prime, what do we know? We know that at x equals 2 and x equals 3, there's a max or a min. Now how do I know that? Because the slope equals 0 at x equals 2, and it's going through the axes, which means there's a sign change. Another way you can think of this is if you were going to make a wiggle graph with f prime and you put 2 and 3 on it, you would see right here, before you get to 2, this function was positive. From 2 to 3, it was negative. And then from 3 on, or right after 3, that's all we really care about, is positive. Okay? So at 2, it went from increasing to decreasing. So that means there's a max at x equals 2. And at 3, it was decreasing and increasing, so there's a min at x equals 3. Okay, so that's what we're looking for in our original functions. So look at each one, and A does not have a max at x equals 2, so forget that. B does not have a max at x equals 2, so forget that. C does, D does, and E does not, so take that out. Okay, so you narrowed it down to 2 of them. Then at x equals 3, there should be a min, and C has that, and D has that, so that's not going to help us. Okay, so the next thing that we can consider is thinking about the second derivative. So if we were given the derivative f prime, if f prime is increasing, then the next derivative, which was f double prime, would be positive. And if f prime is decreasing, then f double prime will be negative. Okay, so let's look at the graph of f prime. So from 0 to 1, it's increasing. So that means on the interval from 0 to 1, f double prime is positive. If f double prime is positive, that means it's concave up. So we're looking between 0 and 1 to see if it's concave up. So this from 0 to 1 is definitely concave up. This one is not concave up, it's like a frown. So D is out and C has to be the answer. Okay, here's number 82, and I don't know why this printed backwards on this also, but whatever, it is what it is. Okay, anyhow, so you're given a function and you need to find where the maximums are. So right now we're just going to look for max and mins and then worry about what's the max and what's the min after. So how would we do that? You take the first derivative and you set it to equal to 0, but you were given the first derivative. So we're just going to take that. And we're going to set it equal to 0. And this is, of course, something that you cannot solve on your own. You're going to need your calculator. So you're going to put that in your calculator. And you're going to set your window from negative 2.5 to positive 2.5. And you will have a graph that looks something like this. Okay, and it's going to hit here, here, and here. Okay, so there are 3 solutions, and you're going to find those using the calculator, and you're going to get this. Okay, so if the question had asked where is their extrema, or where are their maximums or minimums, then the answer would be C. However, this question is only asking for maximums. So let me get a different color. Okay, so you're going to look at the graph, and at negative 0.47, first it was negative, then it was positive. So it was negative, then positive. So that means negative, positive, there's a min. So this has a min. Then at x equals 0.54, it was positive, then negative, positive, then negative. So it's increasing, decreasing, so there's a max. And at x equals 1.39, it was negative, then positive. So that means it's decreasing, then increasing, so there's a min. And this question is asking for when is there a max, and that only happens right here. So the question is saying at what value of x, so it's when x equals 0.54, and that would be this, choice E. Okay, so this is number 84 now. So we're just going to look at the graph and it will tell us everything. So is f of a equal to 2? So here's a, and it's definitely not 2 because at 2 there's an open circle. The answer would actually be 1 because there's a solid circle right there. So a is false. Take that out. Okay. F is continuous at x equals a. Well, at x equals a, you can see there's a hole in the graph, so no, it's not continuous. Take that out. The limit as x approaches a, so as I approach a from the right side, it's 2. As I approach from the left side, it's 2, and therefore it's 2. But this says 1, so that's wrong. But choice D, that one is correct, so it is choice D. Okay, and this is 86, and I think I'm going to stop there after this one because this one's going to take a while. Okay, so we're told that the derivative is greater than 0. If the derivative is greater than 0, that means that f was increasing all the time. So if you look at choice A at the y values, they were not increasing, they were decreasing, so A is out. If you look at B, you can see the y values are constant. They are not increasing, so that's out. If you look at choice C, you can see the numbers are increasing, so that's good. If you look at D, the numbers are increasing, so that one's good. And for E, those are all increasing, so that one's good. Okay? Now we'll go to the next piece of information. Whoops, that one's out, so forget that. Okay, so these three are still in the running. Okay, so the second thing that they told you is that the second derivative is less than 0. So if the second derivative is less than 0, that means that the function must be concave down. Okay, so let's look at each of these. If you look at C, I think if you get a visual, it might be good. So you have a -1, 4, 0, 5, and 1, 6. So if you look at that, that certainly does not look concave down at all because the numbers are increasing and they're all increasing by 1. So if the slope is increasing by 1, so you can see over here, here's my x's, so all my x's are increasing by 1 and all my y's are increasing by 1, so that means that there's a constant slope of 1, which means that the original must be a line, and a line has no concavity, so C is out of the running. So we're getting there. Okay. If we look at D, we have -1, 4 again, 0, 5 again, and 1, 7 again. So we're going to look something like this. And we can see that that definitely looks concave up. So if E does not work for us, we're going to have a problem. Okay, so E is -1, 4 again. And then now it's not 0, 5 anymore, now it's 0, 6. So it's like all the way up here. And then 1, 7. So the jump in the y's went up 2, but now it's going to only go up 1. So when you go up 1, 7, you're going to get something like this. right there. Whoops, I don't know what just happened. But it's going to be like right there. So now your picture is going to look something a little bit more like that. And now you can see that this is now going to be concave down. And that's why E is the winner. Okay, so that's it for that.